So we're gonna do here an example under balancing of rotating bodies. So the thing is, with this example, we must first have an understanding of what are we talking about here. We know that it is important to balance rotating bodies so as to avoid any vibrations which may happen on the system. This is very important, especially in industrial applications such as steam turbines, electric generators. The vibrations can cause like catastrophic failure. Also, another annoying thing with unbalanced systems is the vibrations. So they are very noisy and very uncomfortable, especially like in a car. If you have been in a situation whereby like you are riding in a car whereby it has like wheels which are unbalanced, normally like that experience is not good. So it is important for me to do this example, and so we'll just go through it. Before I go through the example, let me first explain just this important thing. For if you are having a body which is unbalanced, it is important to, in order for you to correct that, you must consider two things, which is static balance and dynamic balance. Static balance has to do with the forces, whilst dynamic balance has to do with the moments. As you can see in the screen, I've put in the correct definitions. So let's just roll through the example, and this should be interesting. So in this example, we have three masses, A, B, and C, which are placed. These are placed on a balance disk as shown at the radius of 120 millimeters, 100 millimeters, and 80 respectively. So we're also told that the masses have 1 kg, 0.5 kg, and we also have 0.7 kg respectively. So we are asked to find the fourth mass which could be added at a radius of 60 millimeters in order to statistically balance the system. So we have all that information. So like now it's time for us to think of a game plan or a plan that we could approach in order to do this question. We know this is 1 kg. We know this is 0.5 kg. And then we know that this is 0.7 kg. So they gave us this information. So here we are asked to find like now what other force could be added to this system in order for the whole system to be statistically balanced, meaning that the forces like will cancel out. So as we can see, like first thing, this is a one plane problem, meaning that all the systems are lying within one plane. So we have three balls. So we're gonna add this other mass here, such that like this system is balanced. So we're gonna call this M, since this is the unknown mass. So so let's go through this question. So just remove everything, start afresh. Let me first start by putting in like a new system. so my lines won't be accurate, but then I'll try. So start by having a center here. We have a center there, and then let's extend this here, and then we have a point mass here, then we have another mass here, then we have another mass here. We must remember that they gave us the angles. So they gave us the angles. The first angle is 30, the other angle is 100, so the other one is 0. So let's just put them there. So the first angle here, they gave us this is 30, then they told us this is 100. So this is C, this is B, and then this is A. 1 kg, 0.5, and 0.7 kg. So yeah, so we have this system. So the best way to deal with these questions is to do a table. And then this table will help us to kind of like visualize and see things like clearly. So I'm gonna draw myself a table there. So let's just draw a simple table. So okay, so we're gonna have plane. This is the mass in kilograms. Then we have R in millimeters, which is the radius. Z in meters. This is the distance. Since we said that this is it's a single plane. So if we have a reference here. So 1, 2. So this is our masses in one plane. So Z represents the distance from a certain point to the masses. So yeah. Then we have MR. MR is in kg millimeters. So it's the mass multiplied by the radius. So that's fine. Then finally we have theta in degrees. Degrees there. So that's fine. So this gonna have A, gonna have B, and then we're gonna have C here. So this is our table. The first thing we're going to say, look at A. We can see that A is in, we said that they're all in one plane. So it's gonna, I'd say plane 1. So this is the plane number. And then the mass of A, it's 1 kg. The radius, they told us in the question that the radius of A is what? It's 120. So we have 120, 108, 180. So it's here is gonna have 120. This distance we're gonna treat it as 0. Oh yeah, we can treat it as 0 because it's just we're not taking it from any reference, so it's gonna be 0. Then M times R, so it's the mass multiplied by the radius, so we still get 120. And then the degrees, the theta is in degrees, so A is 0 degrees. Then we go to B, so B is also in plane 1. the mass of B is 0.5, and then the radius said is 100. This is 0, so 0.5 multiplied by 100, we get half of that, which is 50. And then the angle there, it's what? It's 30 degrees. So you write 30 degrees here. Then we carry on with the last one. So the mass of C is 0.7. The radius is 80. The distance here we're gonna say is 0 as well. When you multiply 0.7 times 80, we get 56. And then the angle there is 100. So we have everything that we have there. But then let's remember now we want to add. So what happens that like now we want to add a fourth mass. Let's add it in red there. So we want to add this mass, which is mass M, and then we're told that the mass, this new mass, is at a radius of what? Of 60. So it's at a radius of what? Of 60. So that's fine. We don't know the angle per se. We don't know what's the angle like from here. So let's put in that one. We're gonna call it, let's say it's D. D is also in the same plane. It has a mass of M, radius of 60, then there's 0. So M times 60, we're gonna get 60M. The angle is theta, we don't know it. So we have everything here. So after this, we're gonna do this using sketches. So that means then using your protractor and your ruler and your pencil. So since we have everything, it's here, we're gonna draw a MR polygon. We want to draw what? A MR polygon. So that means then the values that we need are these ones. We're going to draw a force of 120 at an angle of 0, so it's horizontal. Then from there we're going to have 50, which is at an angle of 30 degrees. Then we're going to have 56, which is at an angle of 100 degrees. So since I'm drawing in a computer, I don't have I'm gonna use another program just to do the sketches. This is the program I'm gonna use. It's an engineering program called SolidWorks. So what I'm gonna do a sketch here. Okay, so we said that the first angle, the magnitude of here is 120. So if you're drawing it using pen and pencil, obviously you're gonna have a scale. Let's say 1 kilogram millimeter is equal to maybe 5 centimeters, depending on the size of the page that you have. So here we don't need a scale because we have the software. So the first one is at 120. No, 120. 120 is at an angle of what? Of 0. So it's a horizontal line. Following that, we have 50. 50 is at an angle of what? Of 30 degrees. So let's go and draw the 50. At the end there, you can have what? I want to put a 50 there. So let's put a 50. Want this one to be 50. There is 50. We said the angle is what? It's 30 degrees. We're going to change this angle to 30 degrees. And then after that, we will have what? We have 56 now, which is at an angle of 100 degrees from the horizontal. So that's fine. So we can draw the third one. No, this one. So we're saying that this is what? 56. So we have 56 here. This 56 is at an angle of, this one is at an angle of 100 from the horizontal. So we're gonna put our 100 there, 100 degrees. That's the angle. Okay. And then finally we close off our polygon just like that. And then we have 120, we have 50, we have 56. We've inputted the correct angles, so we should measure the resultant. So when we measure the resultant there, see, so the length of the resultant is 173.50 millimeters. So that is what we want. So we're just gonna take a picture of this, use the snap software, just gonna snap it. Okay, that's fine. So we did our calculation, inputting these angles, and then we got this polygon. Let's put it here. So using this using the values that we got this polygon here. So but we haven't solved the question. We still want the value of the mass. So what I'm gonna do is this. Just gonna close down what we have there. Let's put it somewhere here. Yeah, everyone's happy. So let me just draw the arrowheads of the vectors here. This is the first vector, which is coming from A, 120. This is the second vector. This is the third vector. And then this is the resultant. So we got that this one is 170. So we have that MD. So 6, we know this is 60 M. This is 60 M. 60 M is equal to 173.5. And then okay, to make it more clear, so 60 M, this is in kilograms, millimeters, and then is equal to 173.50 millimeters. So obviously we want MD, so MD is equal to 173.50 millimeters divided by 60. And if we divide that, we get a mass of 2 something. Let's try to be accurate here. Okay, for now let's just say 2.9 kg. That is my MD. and then that's your answer. They could have asked for an angle. Same with an angle. We're gonna go back here and we want to measure the angle from here till here. So we measure that angle using your protractor, and then that's it. So we're done with the question. I hope you found it interesting and you learned something. Thank you for watching. Thank you.